Ever wondered how your computer manages to retrieve files so quickly? It's like searching for a single book in a huge library, yet it happens in the blink of an eye. How is this possible? The answer lies in some clever computer science concepts, hash functions and hash tables. These might sound complex, but don't worry. We're about to dive deep into the coded universe and decode these concepts for you. So, stay tuned as we unravel the mystery behind this. Picture this, a library where books are sorted by a unique code, not by title. Now you might be wondering, how does the librarian find a specific book? Here's where hash functions come into play. You see, hash functions are like the librarians of the digital world. Just like the librarian assigns a unique code to each book, a hash function assigns a unique identifier to each piece of data. This identifier is known as a hash code, and it's the secret to why hash functions are so widely used in computer science. Let's say you're searching for a particular book in the library. Instead of going through every shelf and scanning every title, you head straight to the section that corresponds to the book's unique code. Similarly, when your computer needs to find a specific piece of data, it doesn't have to sift through all the data it has. Instead, it uses the hash code to find the data quickly and efficiently. But how does a hash function generate these unique codes? It's a bit like magic, but a magic that follows a set of rules. The hash function takes the data and performs a series of operations on it. These operations, or algorithms, transform the data into a fixed-size string of characters, regardless of the size of the input data. This string is the hash code. And here's the catch. Even a tiny change in the input data will result in a completely different hash code. So every piece of data gets a unique identifier, and even the slightest modification will not go unnoticed. This makes hash functions not only efficient but also secure. In the end, just like a librarian quickly finding a book by its code, hash functions help your computer retrieve data swiftly. They're the unsung heroes of the computing world, working behind the scenes to make our digital experiences faster and more secure. So, the next time you're downloading a file or logging into a website, remember the humble hash function that's working hard to get you what you need. Still confused? Let's take a trip to a grocery store. Picture this. You're at the checkout counter, and the cashier scans each item's barcode. Behind these simple black and white stripes lies a unique identification number for each product, whether it's a bag of chips or a carton of milk. This unique number helps the cashier's system to quickly and accurately identify the product and its price. So, what's the magic behind this? It's a real-world example of a hash function at work. Just like the barcode system assigns a unique code to each product, a hash function assigns a unique value to each piece of data. It's a bit like the barcode creator for the data world. This unique value, or hash, is what allows data to be retrieved so quickly and efficiently. In essence, hash functions are the barcode creators of the data world. Now, where do we store these unique codes or barcodes? Enter hash tables. Imagine you're a postman with a bag full of letters, each labeled with a unique code just like our data. Your job is to deliver these letters to their respective pigeonholes. The pigeonholes in this case, my friend, are the hash tables. They are the data structure where we store the data, sorted by the unique codes generated by our hash functions. Each pigeonhole corresponds to a possible outcome of the hash function, and it's here that we store our data, our letters. Now, why is this setup so clever? Well, because it makes finding a specific letter or data incredibly efficient. Think about it. If you had to find a specific letter in a jumbled pile, you'd have to sift through the whole lot, right? But if the letters are neatly sorted into pigeonholes, you'd go straight to the correct pigeonhole and grab the letter you need. The same goes for hash tables. They allow us to quickly access our data, saving us precious time and computational power. So, in essence, hash tables are like the pigeonholes of your computer, neatly storing data for when it's needed. They're the unsung heroes behind the scenes, making sure that when you ask your computer for a piece of data, it can deliver it to you in the blink of an eye. Let's bring it back to the real world again. Imagine walking into a bustling office, papers flying, phones ringing. You're on a mission for a specific file. Now, if this office has a chaotic, messy filing system, you could spend hours, even days, sifting through the paperwork. But what if this office employs a more systematic approach? What if they use a method similar to hash tables? Here's how it works. Just like a hash function assigns unique codes to data, each file in this office is given a unique code. These files are then stored in a hash table, which in this case is a well-organized filing cabinet. Each drawer in the cabinet represents a slot in the hash table. Need a file? Simply use the unique code, find the corresponding drawer, and voila! Your file is there, waiting for you. Like a well-tuned filing system, hash tables keep things in order. making data retrieval a breeze. And there you have it, the magic behind quick data retrieval. We've journeyed through the world of hash functions and tables today, uncovering their roles in generating unique codes for data and organizing this data for efficient access. These are crucial tools in the realm of computer science, making our digital lives run that much smoother. If you enjoyed this tech insight, give us a thumbs up, drop a comment, and don't forget to hit that subscribe button for more from Coded Universe.